The term polymer is used to describe a macromolecule made of many monomers or repeating units. The properties of these polymers all depend on a variety of factors: the monomer unit, the linkages between each monomer, and the intermolecular and intramolecular forces that exist between polymers. In this lesson, we will learn about two classes of polymers: thermosoftening polymers and thermosetting polymers. We will also learn about their properties and how these properties arise. The term plastics is used to describe a wide range of polymers made of monomers, all derived from the products obtained from the fractional distillation of crude oil. You may be familiar with polyethylene, polypropylene, and even polyvinyl chloride. You can learn about the structure of these polymers, how they are made, and their real-life applications from other videos on our channel. Here, we will focus on how these polymers respond to heat and why they respond the way they do. Polyethylene, polypropylene, and polyvinyl chloride are thermosoftening polymers. This means that they soften when heated. When soft and in liquid form, they can be molded into many different shapes. These plastics are used to make many everyday items, such as window and door frames, pipes, wiring insulation, and waterproof clothing items, just to name a few. This is made possible because polymers are not linked together. We can think of it like a bowl of noodles. Although the noodles are coiled and tangled with one another, they are not linked. Like the noodles, these polymers can slide over one another, making these items made from them soft and flexible. In fact, these polymers can only interact by weak intermolecular forces and can therefore be separated rather easily when heated, giving them relatively low melting points. Some other thermosoftening polymers include polystyrene and polytetrafluoroethylene. Thermosetting polymers, on the other hand, do not soften when heated. Unlike thermosoftening polymers, these thermosetting polymers are cross-linked to one another. Can you think about how this might affect the properties of these polymers? Pause, think, and continue when ready. The presence of cross-links hardens the overall structure. A good example of a thermosetting polymer is vulcanized rubber. Rubber tapped from para-rubber trees is a polymer of isoprene monomers. It is a runny liquid that can be processed to make latex gloves, erasers, and party balloons. It can also be used to make car and bicycle tires, though it has to be vulcanized first. For the vulcanization process, sulfur is added, so the disulfide bridges link the polymers together. The presence of these cross-linkages greatly increases its strength and therefore does not soften easily when heated. Let's think about it. No matter how fast you ride your bike, the tires do not change shape. Some other examples of thermosetting polymers include a substance used to make old TV sets and certain types of strong glue. In summary, thermosoftening plastics are soft and melt when heated, whereas thermosetting plastics are hard and do not soften or change their shape when heated.